So, I think, seeing as I've done rather a lot of videos on these Gemini amplifiers, specifically these XGA5000s, which is, the fault lies on the board, on the back of the heatsink. Yeah, so I'm not going to just do my channel to death on these. I've got loads of them to do, but this is probably going to be the last bit of filming I do on one. So the last video was me pulling some bits off of this, doing some fault finding. For some reason, whilst checking all the resistors that are open circuit, kept saying they were short circuit. It's just one of them things when you're filming, you just make mistakes like that and you don't pick up on it till after you've uploaded it. But so yeah, some of these SMD as you can see, some just fell out there and they are tiny. I really don't want to lose them. If I pick them up with these tweezers, which are off camera at the minute, but they are here. So I need to get some of them in, and you can see they are tweezer tiny, splinter size. So yeah, I'll zoom in and we'll have a go with the little fine tipped iron and see how we get on. Right, these aren't in the best position for filming, but as always, it's finding the compromise between what works for the camera and what I can actually get to. So that's the resistor in there, and it is my finger for comparison with my nail that's incredibly long. I find long nails are kind of handy for doing electronic stuff. You know, so, and this is fiddly. There's no easy way to do this. It's just patience and effing about. I mean, I could clean some of the solder off the board, but ultimately I kind of want it on there for when I solder in a second. So let's try and get the highest end down first. So you see now, that's what's called tombstoning. It's basically twisted up on end. So it's try and get, what I'm going to do is get a blob on this side just to kind of hold it. It's getting there. It is so, alright. So you can see it's not on the straightest or the squarest. Let me tilt you down. Whee! God, that's so coarse. So that's the one I've just soldered in. As you can see, it's not perfectly neat on there like the pick and place, but it's not jointed in the middle. There's no bridging between the two sides, and it is thoroughly soldered on each side, and that is the best you can do, really. That's the best you can hope for, is to just get it soldered on both sides and call that successful. So move on to the next one, and it is just try and put some angle on it just to give you something to look at. I go up again, because although it's at the bottom of the shot, it gives the camera something a bit more to focus onto. Yeah, this is wonky, but this is done on the fly. So again, tiny little component on the end of the tweezers. Drop it on the board. And yeah, I've got a small screen on this camera, and sitting from back here looking at the camera, it looks bigger than what I can see with it right in front of me. I like watching the last one of these on my telly downstairs, and you can actually see little things like when I'm desoldering, you can see the solder on like some of the components next to what I'm desoldering melting, and you just cannot see that in real life. So that one a bit easier. There was a little less solder on the board on that one. It is, again, it's a, you know, it's hard trying to get just the perfect amount of solder and just the perfect everything really. So I'll spin this round, and no doubt the camera will lose focus. Oh, it got focus back. Where am I? Here somewhere. There we go. That's the 2K. So that, what am I looking at? Where am I? Where's my tweezers? Oh, there. No, there. There. Ah, of course it's upside down. Yeah, it's upside down in my screen. So yeah, these are the ones I'm soldering now, are the 3.3 ohm base resistors between the emitters of the drivers and the base of the output transistors. This pad looks to have way too much solder on it, so the old solder braid. Now just put a tiny nibble on each one of fresh solder. So where did I put it? I was just looking on my map there for it, but it's there, isn't it, on the board. So like I said, this is just time and patience and effing about. See, I've lost that one. Come back to me. Oh, come on. There we are. You can't force it, you know, if it's stuck on one end, you can't just try and twist it round. It's heat it, try and move it whilst the solder's still molten. Admittedly, with a hot air gun, this would work a bit better, but something I've yet to purchase. I've never needed one enough to warrant owning one. Oh, get back in there. So again, the solder's under it, it's not going anywhere. It's, yeah, you can see it's not the most level of joints, but it's not going anywhere. So yeah, I've got a few more of them to do. I suppose I could try one of them transistors whilst you're set up there. Let me get one of them out, because there's 3 points of contact on them and they are a pain in the ass. Right, let me try and get this 2N5551 in, which is just going to be awkward. So that dropped straight into where it wants to go. But it's not going to be that easy. It's not quite. It's close. It's not perfect, but it's close. So I'm sure there's probably someone who's done this a lot more than me going, no, don't do that, or put a bit of tape on it or something or whatever. And that was a disaster. My solder decided to do that annoying thing where it blobs up on the iron instead of melting. So let's reposition that. Let's try that again. Thank you. Come on, what I need is my solder's not right. I'm going to put a blob on the board here then. As much as I don't want to wet the board because it's a 3 point. So if you put the blobs of solder on the board, when you put the device on them, it holds the device up off the board and then it makes it even harder to solder. But that just wasn't taking, it was just trying to melt to my soldering iron rather than to the component legs. Oh, come on, you bugger. Can't really see it. Oh. Come on. So you can't get Mardy or pissy with it. You've got to just mess about, and they are so small and finicky, and then stuff like that happens. Come on. When it gets stuck against something else and you think, how do you manage to get completely wedged solid on the thing I don't want you to go on, yet the bit I need you to go on, you're just completely unwilling to cooperate. It's kind of like a bungee cord, you know. You think if I tried to hook that over something just by randomly chucking it, it would never work. Yet when you're trying to bloody coil the thing up, it hooks to everything. Right, I've got a bit of solder on there. Let's see what we can coax that down onto there. Right, let's let that cool down a minute, because there's almost no thermal mass in that at all, and the last thing you need to be doing is start poking around with it with an iron, because if you get it hot, you'll just destroy the transistor. You've got a few blobs, a few like quick blasts with the soldering iron, and that is it. You can't. Right, so it's not perfectly lined up. Let me tilt that. So it's not bad. It's slightly towards me, which is going to be the, I don't know, just screens backwards, the whatever side that is, left. Yeah, it's slightly towards the left, but it's in good contact with the other two pads, so I think I can try and solder it at that random angle. So again, you can see, look how big my soldering iron and solder look. So that's a blob on one leg, and again, let it cool down. It heats up quick because it's so small. It also cools down quick. And then a third. You only need a touch on them. You don't need to try and put a ton of solder on it. And so I've got a little whisker sticking up on the first one I did, but now the other two are secure. I can actually just clean that one up. And that is how long it took to solder one SMD transistor, and you'll see how much quicker it is to solder standard transistors momentarily. So I'm going to finish off soldering the, let's zoom you out. So I'm going to finish off soldering the rest of the SMD components. I've got a few resistors and some a few resistors and a transistor to solder on here, and then it's onto some of the through hole stuff, and that's not the through hole stuff. So I'll show you the best way I've figured out of getting all these, because it's got to bolt to a heatsink. Everything needs to be lined up before you solder it. You can't solder it and then try and force the components to fit the hole. So I shall be back momentarily. So got all my SMD rework done. Now the board, so these transistors, you can see, are not soldered in yet. I've determined which are the NPMs and the PMPs. I've not even got the data sheets out. I know I'd ordered some. These are upright. This one I'm putting some uprate transistors on. So these are MJL 3281s. They're rated far higher than the TTC 5200s and what are they, the TTA 1943s that are originally on it. And these ones are MJL 1302s, and the drivers are 15033s and 15032s. So the outputs on these are a standard emitter follower configuration, so both the driver and the outputs that pull the positive swing of the signal are the NPNs, and the drivers and outputs for the negatives are all PMPs. So it's just a case of, this one here says minus VCC on it, so that's the negative, so that's the minus rail coming in. So if I go to the collector terminal here, I'm getting 0 resistance. I'll put my meter in shot if it will go in shot. Let me zoom out. So It's always tangled leads, always. So VCC, yeah, that's it, because if I go up to the rail on this side, just some caps charging or semiconductors biased somewhere, but yeah, that's not a direct connection. So that's the negative rail. So all these transistors up here should be PNPs. So PNP, if I go negative terminal to the base, collector, emitter, then I can go to this emitter because that drives the base. Oh well, no, because they're not connected. So yeah, the base on the inputs, collector, emitter, collector, emitter, and then it should be the opposite on the positive rail. So look, this is the positive rail. Yep, so collector, emitter, collector, emitter, and then collector, emitter. It's an interesting thing with transistors. The smaller they get, the more bias voltage they need. So look, the big power transistors only need 0.5 volts or so. These small drivers need 0.6 volts. And if we come down to one of these small signal transistors, which is going to be a PNP, what is it an MP? It's oh, geez, I'm getting my words lost. If I can get a connection on it, I'm getting nothing. Come on, give me something. Yeah, it was the right way around then. I must have just had a shite connection. Yeah, there we are. Look, that needs 0.74 or so. So yeah, it's the smaller signal transistors need a higher bias voltage to actually get the things to turn on. But so anyway, trying to solder these whilst connected to the heatsink is a lost cause, because as you saw on the ones I tore apart, if I just rummage through the bin here, so yeah, that huge metal tab, it actually connects, that is the collector of the transistor, and it's solidly linked. It's a solid piece of metal, so it will just soak the heat away. You'll be forever and a day to soldering iron, you'll get a shit joint. It's the same for the drivers, and likewise you need to have them bolted in. There's no point trying to line them up, which is a good point. I just make sure I've actually screwed them all on now, they're all in. So it's no point trying to line them up for soldering if they're not tight and in the position they need to be in. So they need to be in their final position of how they're going to be. They don't need to be perfectly level, it doesn't matter. What matters is the insulator underneath when you put them on is perfect. As you can see, look, the board doesn't sit too level. I've had to resolder some components here because it was all right skew-if. So all I'm going to do, I've just got my adjustable iron here, which when you max it out is like 48 watts or something. So I've just got it set on the 30 watt mode. Zoom back in a bit. Slow zoom. Yes, nice. And all I'm going to do is I'm just going to tack the out terminals. So base, emitter, not even going to bother trying to solder them properly. Just literally tacking them on. You could probably, to be honest, solder the base and emitter on the small ones quite happily, which I have done there. That's a little bit more on that bit. Through plated, it likes to, if you get a good joint, it sucks all the way through the board and actually comes out the other end, which is what you want, because some of the tracks go one side, some go the other, and although they do connect through the through plating, you don't want that to be your sole connection if you can get a good joint all the way through. So I'm going to solder the two outer terminals again on the small one, because whilst it's here I can, and I'm just going to tack again the base and emitter terminals on the big output transistors. You can see even this iron, look, it's lost its heat. These things really suck the heat out of an iron. You know, cranking your iron flat out doesn't necessarily work the best way, because what happens is it gets red hot. Well, it might actually go red, but you know, terminology. The iron gets hot and you put it on and you're burning your flux, you're boiling it off, and you're getting too hot a joint, and then all that's happening is the heat gets sucked out the tip of the iron after a few seconds, and then it's too cold. You need either one of those big expensive modern irons with the heating element which is right in the tip. Where am I? Come on. So this one, the element's in the body of the iron, and then the tip just connects into it. But like the real good expensive ones actually have the element with a feedback circuit in, well, feedback temperature sensor in the tip, so it direct heats up. This is heating up the body, and it has to thermally transfer into the tip, and big joints just suck the heat out of it. So now they're tacked in, it's take it all off again and actually get the big iron on it, so bear with me. Right, so I've got the big 65 watt iron, and if that will focus, come on, I don't want to burn my hand. Yeah. So big chunky tip, big thermal mass, hit these collectors hard and fast. You don't want to mess about, you don't want to overheat the transistors. As you can see, this is a nice so somewhere there. Look, it's come all the way through. That's I've got a bit that. Ignore that. That's a chunk off of the. Oh, I've gone way too far for you, haven't I? Anyway. Yeah, I'm on the edge of this camera's focus at this point. Come on, it's trying to focus. There we go. Much better. So I'll just take that piece of crap out of there. So yeah, a quick blast. It's gone through. You can see not too much. Just a little bit on the top, a little bit on the bottom. So let's try the same again on this one. You just can't beat a powerful iron with a big chunky tip when it comes to this, and some thicker solder. So you can see again, straight through, no messing about. You don't want tons and tons, you just want it to just ebb through. So I've got a very small joint on top. The through plating's solidly soldered. And yeah, it's just same again. And likewise, you notice, don't go trying to do all the transistors pins in any one go. Work your way round. So that's, so I could do just a tad more. If you don't really got enough solid, you can always go back and add some more. So yeah. Yeah, and I'll do the same for these ones. Just add a touch more solder. That's cooled down, you can see how much you've got. So yeah, and now it's just do the other legs really won't take much doing at all. They don't have this big collector body they're trying to warm up. So they're just a quick hit and move on. Yeah, so same again. They remember they already had some solder on them from where I tacked them, so yeah, because they don't have the thermal mass to them, if you start trying to flow loads of solder on, you'll just end up with tons of solder running straight through the board and going all over the place. And yeah, that's plenty on there. You just look at the top, so this one looks a little bit dry up top, this bit here. Base terminal isn't overly important because it doesn't carry a great deal of current. Talking a few hundred milliamps per transistor at max, really. So yes, the emitter and collector terminals that are taking all the actual load current, so they're the ones that need to be good. And I'll just put a drop more on that one. And that'll do. I can do these middle terminals with the small iron. Now they're unbolted off the heatsink. It just would have been trying to suck too much heat out of them. So let me unscrew this. If I zoom back out. So that one on the camera there doesn't look like it's soldered, but it is just a trick of the light. It is actually perfectly soldered. It looks like you can almost see through it, but it's like a reflection of something. There you go, you can see there it is soldered. So yeah, I've just got those middle ones to do. And if you look, so you can see I've just got some nice flow, not too much, just a nice little bit of flow. Actually gone all the way through. That's exactly what you're looking for. So yeah, so next thing to do is just solder resistors in and power it up. Ooh-wee. That took some doing. So I replaced that bias transistor. It was wrong. Yes, it's dawned on me. It's quite easy when you think about it to figure out how it ended up in there, because these have to be mounted before they can be soldered to get the holes to line up. These must be actually done manually, and someone's just put the wrong transistor in there. However, I changed that and it didn't make my strange problem which had just appeared go away. My problem being that it was all distorted and there was no bias, and anyway it turned out it was actually a protection transistor activating, and the reason the protection transistor was activating is because the base to it was going losing its connection to the emitter of the transistor that actually feeds it. And it turns out there's a tiny break in a track just here, and I've been changing resistors, trying to reflow solder the transistor itself, look at the joints on the board, and yeah, if you pushed on the board you could get it to go open circuit and closed circuit, so basically it just kept messing about until the intermittent fault became a permanent one. Eventually managed to track it down by getting a wire from the output and touching it to various parts on the protection circuitry that will stop it from activating. So likewise, if you connect the output straight to the base, there'll never be a voltage potential to turn it on, and that would instantly make the amp work. You know, I've had to put a tiny little wire link in to sort the thing out, but
it's between old Walton and
gee, and that has took me some time. It's took me hours to track that up and down, but it's working. It's good, and to be honest, I'm kind of glad the failure node is the way it is, because if that track went open circuit and it didn't make the amp play up, then there'd be no protection on the upper half of the output, and if you shorted it, there's a good chance you'd blow the thing up. So yeah, up and working. I just need to find some fine screws and put it back together. This one has been a challenge. From the moment I got the thing, before I could even get into it, I had to chisel the bloody lid open, and then the amount of sheer damage that was inside the thing from however they blew it up, I do not know, but working finally. So yeah, anyway, actually once I've got it out, look, I'll show you what I've had to do. So that little wire link there, I've had to put that in. Yeah, scrape some track away and put a little wire link in. Boy, was that a hard one to find. It's one of those, even when you know what the fault is, you know, once you've managed to track down what it is that's actually causing the fault you're experiencing. Ooh, still plugged in, don't really mess around, a plugged in amp. It's another thing actually then being able to figure out what it is about that general area which is causing the fault. You know, it's the old it's like taking your amp to repair and, you know, moaning when it comes back like the parts bill is almost nothing. That, you know, it's a couple of quid to even, you know, just pennies. You know, and the tech has only changed a couple of parts, you know, and you thought he's charged me all this time to do that, it's all this money to change a couple of components. You're like, yeah, but the money's in the fault find, you know, you don't, oh jeez, it's just awkward is the word. I don't want to lift on the actual amp body because I don't want to squash stuff, and you're completely blind until you get the holes. There you are. Well, so yeah, there's not like a big red flashing light which says the fault's here. So oh, yeah, so the money isn't for the components, it's for the time and for the knowledge. You know, yeah, if I could seen it on like Facebook and that, oh, I could have changed that. You know, he's charged me $200 and it's like a 50-cent part. I could have done that, save myself a fortune. It's like, well, if you could have done it, you would have done it, but you can't do it. So anyway, I'm waffling on, and you can just see the back of an amplifier. So yeah, as always, thanks for watching, and catch you next time.